So what we do in class is really, really important. So because I will solve all the examples and I will also solve some exercises. So that will give you a general idea of what you need to know in each of these classes, in each of these lessons. Okay. At the end of each class, of course, the video will be available for you to watch again. But I will also post the solution like a file which will show you the solution of all the examples, and everything we do in class will be there available for you to have a look at again. So this is the course outline, and basically that's it. These are not really. Of course, attendance, I didn't mention it, but it's really important. Please make sure you attend. There are two aspects to this attendance. First, you need to come to class, obviously, but also you need to come to class on time, please. Don't turn up 10 minutes, 15 minutes late into class. It's not a great thing because you miss the beginning. Usually the beginning is really important. So please come to class and come on time. That's the general idea regarding the attendance. Now, so that's the overview of this course. Any questions at all? Anyone has anything which is not clear regarding this course? But, okay, everything is okay? All right. Great. So in that case, I think we are ready then to start the first class, first lesson. So let me just take a couple of minutes to, okay. Okay, Hissa, I mentioned this. You will be 2 weeks online and 2 weeks on campus. This is what's going to happen. Like this week, you are online, you are all at home or wherever you are. But next week, I think they will bring you here, and we will do 2 weeks face to face, and then you go. This is basically what happened last semester. Yeah, same idea, same thing has happened last semester. So for the moment, this is how it goes. But of course, things can change because of this COVID situation. We don't know how things will change. Yeah? But at the moment, it's half-half. All right. So now I want to remove this, and I want to open our first. Okay. Right. Okay. Right. Now, can you see them? Can you see this vectors in the plane? Can you see the file? Okay, great. Okay. So we will, yeah, thank you. Okay. So this section is about vectors in the plane. Basically, what is a vector? Yeah, first thing, what is a vector? And how do we say that two vectors are equal, for example? How do we add vectors? How do we subtract vectors? And so on and so forth. Now, vectors are basically quantities which have direction and magnitude. Okay, so yeah, here you can see here yeah, the term vector describes a quantity that has both a magnitude and a direction. Magnitude means a size, yeah, the length of a vector, which could be 2, 3, 4, whatever it may be. Its magnitude, and its direction is basically where is it going, etc. So here is, for example, this vector A here is an example of a vector. Yeah, A is a vector. It has a certain magnitude. Yeah. If I say, let's say this is, so what is the magnitude of this vector A? Yeah, what's the magnitude is usually written like this. Now, if I put those things there, what does it mean about the vector A? What is its magnitude? What is the size of the vector A? Can I see some answers? Yeah. It's not 4, huh? Not 4, not 4. Count carefully, please. Yes, it's 5, yeah? Yeah. The magnitude of the vector A is actually equal to 5, yeah? So 1, 2, 3, 4, 5. 5 centimeters, yeah, it's 5 centimeters, or whatever the units are. Yeah. The magnitude is a length, so it could be measured in centimeters, it could be measured in millimeters, whatever it may be. So that's a vector A with its magnitude equal to 5. Now, because B is in the same direction as A, they are actually parallel, yeah? And also they have the same magnitude, so we can actually say that A is equal to the vector B. Yeah, they're actually equal. Yeah, it's from its head to its tail. Yes, so you need to measure from the beginning to the end, yeah, like this. So that will give you the magnitude of the vector. And because A, B, C, they all have the same magnitude and the same direction, then they're actually equal. Yeah, I will always use an arrow for vectors. In the book, they use the bold. So the vector A, B, C are all equal. The vectors A, B, and C are equal because they have the same direction and the same magnitude. Yeah, so same direction. They're all pointing in the same direction, and also they have the same magnitude. So these two vectors, or these three vectors, same magnitude. So these three vectors are actually equal. Here is a PQ. We can also sometimes write a vector in this form. Yeah. So the initial point is P, and the terminal point is Q. So you have a vector PQ like that, a directed vector which goes from a point P to a point Q. Now, how do we add vectors? In general, if you have a vector AB like this, and you have a vector BC, then AC is the sum of the two vectors. So AC is AB plus BC. So that's in general the way you add vectors. So you have a vector A and a vector B, yeah, like this. Then A plus B will give you this vector here. So this is the vector A plus the vector B. So like that. So that's how you add basically two vectors. So you start with one, and then you bring the other one to the end of the vector, and then you get the vector sum A plus B in this form. So that's the way we add vectors. Okay. Now, multiplying a vector by a number, you start, for example, with a vector u here. Can you see 3u? 3 times u is here. Yeah. So suppose the magnitude of 3 of u is equal to 2, for example. What do you think the magnitude of 3u will be? 6. Yeah, exactly. Exactly. You can see if this is 2, if the magnitude of u is 2, then 3u will have a magnitude of 6. Yeah. How about the magnitude of minus? Can you see what's happening with minus? Minus 2u. What happened to the direction? It's the opposite direction. Yes. So when you multiply a vector by a negative number, then the direction becomes the opposite direction, but the magnitude is equal to 4. Magnitude is always a positive number, girls. Can you remember this, please? The magnitude, yeah, u is given. U is a vector given. I'm just supposing, yeah, I'm assuming this is just, I'm just saying, okay, assume the vector u has a magnitude of 2. What will be the magnitude of 3u? Well, it's going to be 6. And the magnitude of minus 2u will be 4. The magnitude of half of u will be 1, exactly, like that. In fact, there is a general rule. I think it's given in a moment. It's given down there. So please remember now, yeah, you have a vector u. You multiply it by a positive number like 3u, the same direction. You can see they are going in the same direction, but the magnitude, of course, is multiplied by 3. Yeah. If you multiply by a negative number, then it's the opposite direction. The vector will go in the opposite direction. Are we okay with this? Any questions at all with this idea? Any questions? No? Okay, great. Thank you. Always ask, please. If something is not clear, you just ask. Yeah. So what we did here is what we call the scalar multiplication. Or this scalar means a number like 2, 3, minus 5, etc. So you multiply a vector by a number, what happens to it? Okay. Now, in general, vectors are written in this form, A1, A2, with components. These are components. A1, yeah, A1 is in the X direction, A1, and A2 in the Y direction. Okay, so for example, let me give you just a simple example here. Suppose I have this vector here. Yeah. Now this is 1, this is 3, this is 1, this is 4, say. And then I have this vector A. What is the x component of the vector A in the x direction? 2. Yes, exactly. Yes, 2. In fact, what you do is you just take basically 3 minus 1, like that. And then in the y direction, yeah, is it 3? Are you sure it's 3? It's always, by the way, it's always this, the end minus the beginning. The end minus the beginning. The end point, yeah, the end point is here. Yeah, the end point is 3, 1, and the beginning is 1, 4. So you do always, yeah, this is the terminal point, the terminal side, and this is the initial side. It's always the terminal minus the initial. So it's actually minus 3. Yes. We'll come back to this later. No problem. Yes. It's the vector A is 2 minus 3. Okay. And the magnitude of a vector A, this is an important rule. The first rule, in a way, in this course, the magnitude of the vector A is always the square root of A1 squared plus A2 squared. So if I want the magnitude of this vector A, so what will it be? Okay, so it's 2 squared plus, yeah, minus 3 squared, like this, exactly. Yeah. So in the end, the magnitude of this vector A, which we just created, so it's going to be square root of 13. Yeah, square root of 13 is the magnitude of the vector. By the way, this rule comes from Pythagoras. Yeah, you want the size of A, it's A1 squared plus A2 squared, and then you take the square root of that. So that is, so first important rule, finding the magnitude of a vector from its component. Now, second rule, the way you add vectors is given here. A1, A2. If you want to add another vector, B1, B2, then it's this plus this. And then this plus this, like that. Okay? So that's the general idea of about adding. Yeah. So if I say, I just give you a couple of examples here. On the side, if I have a vector A, which is 1 minus 2, and then a vector B, which is 3, 6, then if I want A plus B, then A plus B. Okay, so what will be the vector A plus B, girls? Anyone? So it's going to be 4, yes? So you just add the, yeah, it's you just add this and this plus this. So this will give you 4 and 4, 4, yeah, I think that's basically, yeah. So it's another vector, yeah? It's going to, when you add two vectors, of course, when you add two vectors, the answer is another vector, so it has to have two components like this. So that is A plus B. If I wanted, let's say -2, yeah, let's give you another rule here. When you have a minus, the same thing, it's minus and minus. If you take a vector and you multiply it by a constant, then you just do this multiplication like that. So these are rules for adding. So for example, if I want minus 2a, what will be the vector minus 2a? No, okay, why minus 8? Yeah, so it's minus 2 that I multiply by 1 minus 2, yeah, like this. And then you multiply like this. Yeah, so so it's going to be minus 2. So it's going to be minus 2, 4, yes, like you said. Thank you. Yeah, minus 2, 4. For the addition, yeah, if I have a vector, okay, A, let me take another vector, 3 minus 6, and I have another vector. So this vector A is 3 in the x direction, minus 6 in the y direction. So the vector A, in a way, you can think of it as this vector A, yeah? 3 here, and then 1, 2, 3, 4, 5, 6, minus 6 down. Yeah, so that's the vector A. So we can write it as 3 minus 6. The vector B, let's say minus 2, 8. Yeah, another vector like that. Now, what is A plus B? Suppose I want to add these two vectors. So what will be the answer? A plus B. You just put these plus and these plus like this. So it's going to be 1, and like some of you already, Hissa, Mahra, yeah. So 1 as the first component and 2 as the second component. So that is A plus B. Does that make sense? Yeah? Is this okay? Okay. All right, great. So that's how you add two vectors. It's a very simple operation. Really, really simple. If you have A and you have it in this component 3 minus 6 and B also in terms of its component, then if you want to add, then it's very, very easy. No problem. Same thing if you want to multiply. Suppose I want now the vector 3A. What will be the vector 3A? Can we write the answer directly? 3A will be 9. Yeah, great. Thank you, Noor. Yeah, Fatima. So it will be 9 and minus 18. That's it. That's the vector 3 times A. Yeah. Now, okay, that's multiplication. I can do maybe I can do B minus A also if I want. What will be B minus A? Can we have a, can you think, can you see what the answer will be here? If I want the vector B minus the vector A, it's going to be minus 5, yeah? Minus 2, minus 3, which will give us minus 5. And then 8, it's not 2, yeah? 14, yes, 14. So it's minus 5, 14, like this. Does that make sense or no? Girls, please. Yeah? Okay, great. Okay, so we can add, we can multiply, we can subtract, and so on. So we can do this very easily using all these rules that we just mentioned. This, what is written here, is what we already mentioned before, which is when you multiply, what happened to the magnitude when you multiply the vector by a certain number? The magnitude is also multiplied by that number, but in terms of, yeah, absolute value. So we need to, I can write the rule here, is that the magnitude of C multiplied by a vector A, where C is a number, is going to be the absolute value of C multiplied by the magnitude of A, like this. Let me just give you an example to explain what is written here. Suppose you have a vector A, and you know that its magnitude is equal to 5. Let's say like this, yeah? Example. And the question is, what is the magnitude of 2A? What will be the magnitude of 2 times A? 10, yeah? It's going to be 10, yes? It's going to be the 2 multiplied by the magnitude of A, so it's going to be 2 times 5, which is going to be 10, yes? Like this. So you're multiplying the vector by 2, its magnitude is also multiplied by 2. But however, be careful, when you multiply by a negative number, don't use -3. What do you need to use here? Not -3. You need to use, yeah, it's going to be in the opposite direction. Fine. Yeah, it's going to be the absolute value of 3, which is 3. Yeah, it's 3 multiplied by the magnitude of A. So it's 3 times 5. So it's going to be 15. So that's basically what this rule says. Only positive, yes. Always, always you have a minus, make it into plus. So that's why we put the absolute value here. Does that make sense? Yes? Are we all okay with this? Yes? All right, great. Fine. Okay. Okay, so here is the first example. We have a vector A, which is 2, 1, and the vector B, which is 3 in the x direction, -2 in the y direction. And we want to compute all of these things. So first, A plus B. Okay. I'm sure you can do all of this without too many problems. So it's going to be, yes, thank you, Mahara, Noor, yeah, Saliha. Yeah, good. So that is just 2 plus 3, which is 5, and then 1 plus -2, which is -1. So that's fairly easy and no problem. Part 2, B, is 2 times A. What is 2 times A? So 2 times 2, 1. So it's going to be, thank you, yep, 4, 2. Thank you, girls. Yes. It's always good to participate, please, just as much as you can. Doesn't matter, you make mistakes, that's really not important. Important thing, I want you to contribute to Give us your ideas, whatever you feel. Okay, so we want to find now 2 times A and then 3 times B. Okay, so let me write it like this. 2 times A, what is A is 2, 1, and then plus 3 times the B, which is 3 minus 2. So then what we want to do is calculate this first, which is 4, 2, yeah? This is going to give us 4, 2, and then plus this, which is 9 minus 6. Great. 9 minus 6, and then we just add these two together. Yeah. Then we add these two together like we did it before. So it's going to be 13 and minus 4. Thank you very much. For Zaina, yes, Wadha. Okay, great. So that is the answer of this operation. Now, in the same way, now with D, we want 2A minus 3B. So we want 2A minus 3 times B. Yeah? Okay. So 2A, we can write it if we want directly, maybe just 4 2s, huh? And then minus 3 times B, which is 9 minus 6. And then we complete this. It's going to be, yeah, minus 5, 8. Okay, great. Thank you, Mahra. Yeah. Okay, Sheikha, yes. Okay, so minus 5, 8 is the result of this operation. Okay, and finally, we want the magnitude of 2A minus 3B. So the magnitude of 2A, which one, Hissa? This one, D? D? Okay, it's 2A, yes. So you find the vector 2A, which is this one. We already found it, by the way, here. Huh? 2A is 4, 2. And then minus, yeah, minus is there. The 3B, yeah, 3B, already also found it here. 3B is this vector. And then you take the minus. 4 minus 9 is minus 5. And then 2 minus 6, which will give you the 8. So final answer. Is that okay? Or is there something? Is that okay? Yeah? All right. Finally, I want the magnitude of 2A minus 3B. I want the magnitude of that. Now this vector is already found. We found it here. Huh? It's minus 5, 8. So I want the magnitude of this. So it's going to be the square root of, remember the magnitude, the rule? Yes, Mahara, yeah. But so it's going to be minus 5. Can I just say, please use brackets here. Use this parenthesis or brackets, yeah, when you do this. So it's minus 5 squared plus 8 squared, and then you just, so it's the square root of 89. Thank you, Norris. So it's 25 plus 64. So square root of 89 is perfectly fine. And no, you keep it as minus 5, but you square it, yeah? It's A1, but you square it. Please be careful, yeah? Keep it as minus 5. No, You don't change it. It's fine. In general, remember, in general, the rule is whenever you have the magnitude of A1, A2, it's the square root of A1 squared plus A2 squared, yeah? Like this. So A1, A1. No, don't change anything. Except that if it's a negative number, then you need to use a bracket. These brackets are really, really important. If you don't use them, no, you will not get the right answer. Is that okay? Yeah? So we need to be a little bit careful here. Yeah, a little bit careful. Okay, the vector 0, it's just the vector 0, 0. That's okay. Yeah, minus A is the additive inverse of A. It's okay. Now, parallel vectors, we'll talk a lot about parallel vectors in this course, so it's important to understand what they are. It's basically two vectors which have the same or opposite directions. So parallel vectors can be like this, A and B, like this. These are two parallel vectors. These two vectors, do they have the same direction or opposite directions? The same, yeah? They are pointing in the same direction. So these are parallel vectors, no problem. Yeah, the same, thank you. You can also have parallel vectors like this. These also are two parallel vectors. But these two vectors now, how are they? The same direction or opposite? No, they are parallel, not anti-parallel. They are actually parallel also. They are parallel, but they have opposite directions. Yes. So these two vectors are parallel. Yeah. It's okay. They are parallel. They have the same direction. These two vectors, are they parallel or not? These ones. Parallel or not parallel? Yes, they are parallel. But what? They're parallel, but their directions are opposite directions. Yeah, they're also parallel. Yes, they're also parallel. Like that. Okay. Now, the question now is, if I give you two vectors, how do I know if they are parallel or not? Yeah. Determine whether the given pair of vectors is parallel. Like this vector and this one, are they parallel or not? Well, we will see in this course maybe 2 or 3 rules which will allow us to, by the way, I will do another maybe 10 minutes and we will take a small break, okay? I'll give you a 5-minute break just to. Okay, now, this pair of vectors, are they parallel or not? Well, the way we're going to do it for the moment is to look for a constant C. So we're going to try and solve, is the vector B equal to a constant times A. So can I find the constant C which satisfies this condition here? Okay, because two vectors will be parallel if one of them is a multiple of the other one. Maybe B is 3 times A or minus 4 times A, etc. So I want to find the constant C which satisfies this equation. So that's how, for the moment. Later we will see other ways, but for the moment, that's how we're going to decide. So B, I'm going to write this. Yes, so I'm going to write this equation, and I will try to solve it for C. Can I find the constant C? So let me write this equation. So I will write 4, 5 is 4, 5 equal to a constant times 2, 3. This is what I want to see. Can I find C like this? Then I will write this as 4, 5 equal to, let me multiply this. So 2 times C and 3 times C. Now, from here, I get two equations. This 4 must be equal to 2C. So 2C equal to 4. And the 5 must be equal to what? This 5 should be equal to 3C. So 3C is equal to 5. Now, this is giving us C equal to 4 divided by 2, which is 2. And this equation is giving us C equal to 5 over 3. Now, these two numbers, are they the same? Are they the same? No. So there is no C. So basically, I cannot find C which satisfies this equation because I'm getting C equal to from the first components, and I'm getting C equal 5 over 3 from the second component. So that means there is no, the vectors A and B, so these are different numbers. So the vectors A and B, can you complete this? Are not parallel. Thank you. Yes, are not parallel. Yeah, that's the conclusion. So if you try to solve the equation and you are getting two different numbers, 2C's, then this is telling you that the two vectors are not parallel. Now let's try B, and then we can take a small break. B, we have the vector 2, 3. So that's our vector A. And we have a vector B, which is minus 4, minus 6. In fact, you can see here immediately that B is a multiple of A. It's something multiplied by A. Can you see what this something is? Exactly, it's actually minus 2. Yeah, it's in fact minus 2. Which means, because B is equal to minus 2A, that means A and B are actually parallel. But let's solve it. So the same thing, what I'm looking for is there a constant C which satisfies this equation? So I will write minus 4 minus 6 equal to C times 2 times 3, which means minus 4 minus 6 equal to 2c and 3c, which means two equations. What are the two equations? So what, yeah. Yes, so the two equations is that 2c must be minus 4 and 3c is minus 6. From here, yeah, exactly. From here, c is minus 4 divided by 2, so it's minus 2. And from here, c is also minus 6 divided by 3, which is also minus 2, and they are equal. So fine. So that means this time they are parallel. Yes, because B now, so B is minus 2 times A. That means B is like this and A is like this. They are in opposite directions. Therefore, so A and B are parallel. Like this. Any questions so far then, girls? Anything from what we said so far? Are we okay with these ideas of vectors? Okay, clear? All right, so let's take maybe a 5-minute break and then we'll come back and continue this, okay? Or do you want to continue directly? It's up to you, huh? But maybe 5-minute break. What do you say? 5-minute break or no need? Yes? Okay, all right. Take 5 minutes then, girls. hear me? Just checking. Yes, thank you. Yeah, thanks. Thank you, guys. Okay, any questions at all before I continue this? Any questions? Anything you want to ask? No? Okay, so um, let's have a look then at the rest of this lesson on vectors. Okay. Here is a theorem which basically gives us some rules that we can use when working with vectors. The addition is commutative, obviously, because when you take a plus b, it's exactly the same as b plus a, so it doesn't matter how you do it, a plus b or b plus a, the answer will be the same. If you have three vectors that you want to add, you can add b plus c first, and then you add the a to that, or you could take a plus b and then add c. So this is called the associativity. A plus 0 is a plus minus a is 0, and so on. So there are different rules that you can use when you work with these operations. Now, finding a position vector, well, I mean, there's no need, I think. You know, when you, I see what you mean. Yes. Do you need to memorize this? I don't think so. I think because they are automatic. When I give you two vectors to add, yeah, for example, A and B, and you want to add them, doesn't matter you do 1 plus 3 or 3 plus 1, it's exactly the same thing. So A plus B, so 3 plus 1 is 4, 5 plus 2 is 7. So it's okay, and the order doesn't matter. So there's no need to memorize those, they're fine. They're automatically known. Yeah. Okay, now finding the position vector, that means you go from a point to another point, an initial point, to a terminal point like this. So like in part A, the initial point is 2, 3. The final point here, or the terminal point, is 3 minus 1. And you want to find this vector, let's say A and B. Let's call this AB. So the vector AB, the way you do that, I think I mentioned this already. So it's this, yeah, it's the final minus the initial, exactly. So it's 3 minus 2. So it's this minus that. And then the other component will be minus 1, minus 3, like this. Yes. So it's going to be 1 minus 4. So that's the vector AB. Okay? So that's the general idea. So the rule is, if this, let me write the rule, if this point is x1, y1, and this point is x2, y2, then the vector AB will be x2 minus x1, and then y2 minus y1. So that is the rule that you need to use to work out. Okay, so that's part A. Part B, the initial point this time is B. So this time you're going in this direction. So I want the vector BA this time. So the vector BA will be, of course, it's the 2, yeah, 2 minus 3. Good. Yes. No, thank you. 2 minus 3. And then 3 minus 1, like this. So it's going to be, so it's going to be minus 1, 4. Yeah. The opposite of AB, exactly. You can see this and this are exactly the opposite of each other. Yes. One is 1 minus 4, the other one is minus 1, 4. So, yes, the opposite. Okay, so that's the position vector. Are we okay with this? Yeah. So, generally speaking, if you have a point P, yeah, point P, let's say 2 minus 5, and Q is minus 7, 10, you want the vector PQ. So what will be the answer? The vector PQ. So this is just another example. So yeah, minus 7, minus 2, which is minus 9. Thank you, Saliha there, yeah, Saliha. Minus 9, and then 15. Yeah, thank you. Yes, that's great. Fairly simple, no problem. So this is the vector which goes from P to Q. Now here, the vectors I and J, these are 1, 0 and 0, 1. They are here. You know, I is the unit vector, what we call the unit vector on the x-axis, and J is the unit vector on the y-axis. Then we can write, you can see if you have a vector A1, A2, you can see that it's going to be A1 multiplied by I plus A2 times J. So that's another way of writing a vector. So vector, you can write it in this form, or you can write it with I and J in this form, like that. So that means, for example, if you have a vector 5 minus 3, this vector, I can write it also. Sometimes it's useful to write it as 5 times I plus minus 3J. Yeah, exactly, like this. Okay, so, or if you have a vector 0, 5, this is just the same as 5J. Thank you. Yes, like this. Okay, so these are the two vectors I and J, which we can use sometimes. Finally, this idea of finding a unit vector in the same direction as a vector A. Unit vector U means the magnitude of U is equal to 1. That's what unit vector means. So this is the rule. For any non-zero position vector A, a unit vector having the same direction as A is given by this formula. So what do we mean by that? Is like this. So you have a vector A, I give you a vector A, which has a magnitude. We don't know what its magnitude is. Could be 4, 5, 6, 7, whatever. And the question is, find a unit vector. Let me use a different color here. I want to find a unit vector u exactly in the same direction as A, but the magnitude of u is just equal to 1. How do I get the vector u like this? Okay? Basically, suppose the magnitude of A, is 6. How can I get the vector u with a magnitude of 1 only? What do I need to do to the vector A? Suppose its magnitude, the magnitude of A is 6, and I want to find a small vector with a magnitude of 1. What do I need to do to A? Divided by 6, exactly, yes. So I take the vector A and just divide it by 6, yes? Which is basically, what I do is the vector A, and I divide it by the magnitude of A. That's exactly what we are saying. So you want to find a unit vector, u, then it's the vector A that you divide by the magnitude of A. Exactly. That's the rule for finding a unit vector in the same direction as A. So let me do this example. Find a unit vector in the same direction as, so there are maybe a couple of steps, yeah? The first thing you need to do, yeah, is to find the magnitude, exactly. Yes. So first you find the magnitude of A, which will be the square root of 3 squared plus minus 4 squared, which is 5, sir, which is 5. And then you say, okay, the unit vector then will be 1 over 5, which is like dividing by 5, multiplied by the vector A, which is 3 minus 4. And then we can leave it like this if we want, or you multiply. So it's going to be 3 over 5 and minus 4 over 5. And that is basically the unit vector in the same direction as A, which is given here. Okay. Now you could check that this is really, how can you check that this is really a unit vector? How can you check that this vector here is really a unit vector? Well, by the way, what do I mean by a unit vector? What do I mean by a unit vector? Okay. Sorry. Yeah. No, unit vector means its magnitude is 1. Yes, that's what, yes, a unit means 1. Yes, a unit means 1. So a unit vector means the magnitude is equal to 1. So please be careful about that. A unit vector means a vector of magnitude equal to 1. Yes, a vector A with a magnitude equal to 1 is called a unit vector. So you could check take a calculator and check that the magnitude of this vector is really equal to 1. Yeah, you could check that by taking the square root of 3 over 5 squared plus minus 4 over 5 squared. Then the answer should be equal to 1. Yes, it should give you 1. Yes. So this vector u has a magnitude of 1, and it's also in the same direction as the vector a, because it's 1 over 5 times a, so it's okay. So let's repeat again. What is a unit vector, girls? What do we mean by a unit vector? What do we mean by a unit vector? Magnitude equal to 1. Okay, that's it. Yes. For example, if I give you half, this vector, is it a unit vector or no? Are you sure? This vector u, is it a unit vector? It's not, sir. It's not a unit vector. Because what is its magnitude? If you work out its magnitude, it's not going to be 1, yes? It's not going to be 1. But if, yeah, so this definitely not a unit vector. If you try this one, if you try this vector v, okay, can you hear me now? Yes? Can you hear me now? Yes, okay, thank you. Okay, great. Okay, now last example, yeah. Last example here, at a certain point during a jump, there are two principal forces. Of course, you all did physics, and of course, forces are actually vectors. Yeah, a force is a vector. It has a direction. It has a magnitude. So it is a vector. So acting on a sky drive, the gravity G is a vector here, exerting a force of 180 pounds straight down. And then, so that's the first force, G. Because it is going, it's a vertical force. Yeah. So what will, how can we write that as a vector, girl? If I want to write G as a vector, what will it be? yeah, into the vector G is going down like this. So its X component is 0. Yeah, 0. Yes, thank you. It's 0. And also because it's going down, it's minus 180. Yes. So that is actually the gravity as a vector. There is the resistance of the air, 180 pounds up and 30 pounds to the right. So it's going to be 30 and also 180 there, like that. So that's basically air resistance. And then what is the net force? The net force means the total, the sum of these two forces. So the net force is G plus R. So we add the two forces, and of course, very easy to do that. So it's going to be 30, yeah, 0, which is this force here, G plus R. So it's a horizontal force going to the right. Yeah, horizontal because the second component is 0. So it's just along the x-axis only, and it's 30 pounds to the right, like that. Okay, so that is basically, I think we'll leave this one, or we'll not, we'll leave 1.6. So, now, here we have, I want to do some of these questions here in exercise 1 and 2. Sketch the vector 2A. Okay, so we have A. So 2A, yeah, of course, will be like this, yeah? The vector 2A will be twice as big as A, and it's going to be in the same direction, 2A. How about minus B? Minus B. We have, yeah. Yeah, it's the same as B, but in the opposite direction. So I could draw it from here and in the opposite direction. So minus B will be like this. A plus B. Remember the way we do adding. So I go A, and then I add the B. So I can slide. B is like this. Yeah, yeah. And then what we get is this vector now is A plus B, like that. Okay? So A plus B. And then, yes, 2A is given here, and minus B also is given here. So minus B is this vector. So in the end, if we add 2A and minus B, then we will get this vector 2A minus B like this. Can you see the way it works here? Yeah? Yes? Okay. No problem. You will not be asked in general to do these kind of things, but it's important to understand if you have B, how to get minus B, yeah, or if you have A and B, how to add them, and so on. But in general, you will not have to do this. Yeah. Okay, these are fairly simple. Okay, I want to do A plus B. So what will be the answer here, girls? A plus B, fairly easy. 6, yeah, 6, 3 is good. Yeah, thank you. And then A, yeah. Yes, Noor, what's up? Yes. So it's 2 plus the 3. Sorry, 5, yes, 5. Thank you. Yeah, 5. I forgot how to add. 2 plus 3, 5. 4 minus 1 is 3, so 5, 3. Yeah, that's fine. And then A minus 2B, or not 2B. So A is 2, 4, minus 2 times the B. What is 2 times B? So I want to write this vector, 2B. 6, yeah, 6 minus 2. Yeah, good. And then after that, we just do this subtraction. So minus 4, great, yeah, minus 4 and 6. Okay, good. Then we have, yeah, good. Then we have 3a. I want to find the vector 3a. 3 times a. So that's 6, 12. Yeah, 6, 12. And finally, I want the magnitude of 5b. Okay. Yeah. Okay. 5b minus 2a. So first, of course, I need to find this vector 5b. 5b. What is 5b? So that's 15. Yeah. 15 minus 5 minus 2a. So minus 2a, which is 4, 8. Yeah. Thank you. Thank you, girls. Hassa, yes. Mahra, Watha, Salih. Salih, yes. No. Okay. Good. Now, I then find the vector inside. So 15 minus 4 is 11. Yeah. So that will be 11 and minus 13. And now I am ready to write the magnitude. Now you take a calculator and the square root of 11 squared, which is 121 plus 169, so 290. Yes? Square root of, can you check that? Square root of 290, yeah, square root of 290. So that is the magnitude of this vector 5a minus. 5 is exactly the same, yeah, except a, what does it mean about a? If you want to write it in the component form, what is a? 1, 2, yeah, So A is 1, 2, and B is minus 3, 1. And then you do exactly what we did in the previous question. So you can do that without too many problems at all. Okay, let me do one last thing here. A and B, are they parallel or not? So determine whether the vectors A and B are parallel. Do you remember how we tried to do that? Yeah. So we need to solve the equation B equal to C times A. Yeah. So you need to solve this. If you are getting one value of C, then they are parallel. If C gives you two values, that means there is no solution. So then that means they are not parallel. So you write this minus 4 minus 2 equal to C times 2, 1. Yeah. After this, what's the next step? Yeah, 2C, yeah, equal to minus 4. But let me write this like that. That means we are getting two equations now. Two equations. 2C must be equal to minus 4. And C must be equal to minus 2. Well, this equation will give us actually C equal to minus 2. So they're exactly the same. So yes, so that means they're equal. So C is equal to minus 2. So A and B are parallel. Like this. They're parallel. By the way, are they in the same direction or opposite directions? The same direction? Look at this equation. What was the C? The C was minus 2, yeah? So that means B is minus 2 times A. So what is this telling us? Yeah, it's telling us that, yes, A and B is telling us two things. They are parallel, A and B are parallel. And it also telling us that they are in opposite directions. Why is it opposite? What is telling us? It's the minus, yeah? The minus sign is telling us that A and B are actually in the opposite direction. So if you want to, basically B is like this, and A is in the opposite direction, but only half the size of B. Okay, I think we've done enough work today. Good work, girls. I'm really happy that you. Yeah. If B was B equal to A, it will be in the same direction. Yes, Hissa, yes. Yeah, definitely. So it depends on the C. Positive. If C is positive, then the two vectors will be in the same direction. Yes. If C is negative, then they will be in opposite directions, like that. They give bonus marks. We will see. I certainly will be able to help you. Okay, no problem. Uh, you work and you leave the rest to us. We will help you as much as we can. Okay, guys, have a nice day and take care of yourselves. Okay, so. Any questions at all? Anything you want to ask? Are we okay? Not too fast today? It was okay? All right then. Have a nice day. Okay, now, Sarah, the class is online or campus? I already said half, yeah? Half of it online, half of it on campus. Can you hear me? Sarah, you asked the question? Yes? Yes. So next week, I think you are coming online. You are coming to the campus. So 2 weeks on campus, 2 weeks online, like this. For the moment, yeah, we don't know. Maybe they will change later. We don't know. Okay? Like that.